Hello and welcome back to the Fullerton College Prepress class. This is Professor Ben Hewitt, and today we're taking our second video stab at PIA's Prepress Training Handbook, Section 6.8 Review. That's right, this is the end. All right, so we picked up last time, we dropped off talking about fonts and faces, including a few unsolicited opinions of mine about typography and what you should and should not use. Anyways, moving on. We're talking about type alignment. And you know what? This slide is not nearly good enough to tell you about these bottom ideas here, because we're talking about which way you arrange your type on the page to be seen. And I'm not going to go into all the details of the pros and the cons of all of them, but golly, at least we could take a look at what they do. So, text alignment. The top one is called flush left or ragged right. Well, you know what? Close these off. I'm professional. So, flush left or ragged right means the left side of your page is a solid vertical line and all the text aligns there. It's just aligned to the left. The right side is the end of sentences, the end of words, the end of lines, as best as you can fit, sometimes with, sometimes without hyphenation. In fact, if I go in here, and if I turn off the hyphenation, there you go, it's even more apparent what it's doing, because then you get a more ragged edge. That's standard book typesetting. Below that, we have flush right or ragged left. Ragged left is harder to say out loud than you would think. Ragged left, yeah, exactly. See what I mean? I can't do it. Anyways, the right side is the alignment and the left side is however it fits. Centered is hopefully fairly self-explanatory. It's in the middle, guys. Justified. Justified means your text is set so that it fills the entire width of the space you put it in. That means it plays around with the spacing between letters and between words to make it happen, like in the word justified, because that is a single word set to justified, so it spaces it out to fit the whole thing. Down below that, we have runaround. Runaround, also known as text wrap, means the text goes around things. In this case, it's going around the text box that has the word runaround in it. See what I did there? And lastly, initial cap, aka drop cap, is when the first letter is made bigger. You could choose how big you want it in InDesign, and it will let you go well beyond any reasonable purpose, all the way up to the extremes of taking up the whole page with a single letter. You could do that. It'll let you. I don't know why you would do that. Perhaps there's some artistic merit to it somewhere. This is great for letting people know where a chapter starts or a newspaper story starts. It's a good way of leading the reader in. Oh, I said I wouldn't give color commentary, just the facts. Sorry, guys, play by play. Initial cap means the first letter of the first line is increased to be more than one line in height. Also, as a fun little side note here, because I can't get away from it, this is the only place in a computer where 0 equals 1. Because you choose how many lines does the initial drop cap take. If I take that, you say 3, 4 lines. If I reduce it to 3, 2 lines, 1 line means the initial cap takes up 1 line, and 0 means it's turned off. Weird, right? 1 and 0 mean the same thing only when you're talking about initial cap. Otherwise, 1 and 0 are the most polar opposite things you could possibly have on a computer. They are the fundamental basis of off or on, but in this one weird case, they mean the same thing. Isn't that weird? Anyways, let's switch back to our normal lecture. So that's type alignment. Color specification terminology. It's important to understand all these language terms about process color. That means it's being built out of cyan, magenta, yellow, and black, CMYK. You're printing thin films of dots of those colors on top of each other on the paper to build through that process. See what I did there of laying them on to make what color you want to see. A press unit is all of the equipment in an offset or flexo press, or any press really, required to make a single color. All the rollers, all the ink, all the fountains if applicable, or the analoxes if you're talking flexo, everything, it's basically a press unit is a press. Traditional printing presses, starting back at the days of Gutenberg and way farther back if you go to China when they invented it, who knows how early, they all print one color. So a printing press prints one color. A multicolor press is really nothing but a bunch of smaller presses stuck together end to end to end, printing on top of each other's output. Rather than printing on the same press 4 times, you glue 4 presses together and run it through once. So a press unit is the single part of one of those that prints one color. A spot color is a color of ink that is the color you want. That means that you print a color on a single plate and it prints that color because you've already mixed that ink color. This is good for corporate logos and things. And the version of this, the example everybody points to because it's the most commonly understood one, think like the color red from Coca-Cola. I hope I'm not in trouble for mentioning them. There goes my copyright status on YouTube right there. But anyways, everybody knows when you say that red color, everybody knows what color that is because that's a spot color. That is a managed color. Everywhere in the world, on every single thing it's on, whether it's t-shirts, hats, beach umbrellas, soda cans, boxes, billboards, newspaper ads, it is set to look the same. There's actually a few variations on it to account for those different substrates. But yeah, that is spot color. You don't make that using cyan, magenta, yellow, and black. You make that using a can of ink specially mixed with a secret formula, just like the drink itself, that says Coca-Cola Red on the outside. Process build is a way of producing color using process color. A color model is the way color is being described. Is it CMYK? Is it RGB? Is it some other form like LAB color? That's the color model. On the right, these are all different matching systems. The most common and most famous is Pantone. Pantone matching system with its unfortunate acronym. Sorry, everyone. I didn't make this up. I didn't choose it. I wouldn't have chosen that. But anyways, the Pantone matching system is the first one really that tried to wrangle the world of color into a controllable space by making pre-mixed formulas of spot colors that anyone in the world can purchase the Pantone primary colors, physically mix them together in a jar and put them on press and get the exact same output. That means that if you like that blue color, you could print that exact blue color again anywhere, and anyone who likes that exact blue color can also do it. Pantone Color Bridge is one of my favorite forms of Pantone. This is a series of spot colors that are also possible to be printed by CMYK building. Not all spot colors can be achieved using process color, but the Pantone Color Bridge is a translation guide, like an English to Spanish dictionary that translates spot color to process color. And you can see also which colors translate better and which ones don't do so well. I quite love my Color Bridge book. It's one of the most useful tools in my arsenal. Toyo. This is a spot color system from Japan, in case Toyo doesn't already sound a bit like some other, Japanese companies. Anyways, that's another one. Theirs has the gimmick of having holes punched in their swatches so you can look through their swatch book at the thing below to see if you can figure out the match. Now, True Match and Focal Tone there at the bottom. Also, they did not include HKS on here, but there's a German Pantone. See what I did there? A German spot color system called HKS, and that's an acronym for the different companies that are all involved. We're not going into all of that right now, but HKS is the German version of Toyo or Pantone. Now, True Match and Focal Tone, those are swatch books and matching systems, but they do not use spot color. Those are process matching systems. True Match and Focal Tone is short for color tone. I believe it's British. And those are European, well, not all European, the British one is. Those are ways of checking colors and showing swatches to clients, which, by the way, one of the most powerful uses of Pantone isn't necessarily printing exactly matched spot color, but by nailing down discrete shades of color that you can actually talk about with a client. So they're not saying, no, I meant robin's egg blue. This is clear sky blue. That doesn't work if you're just trying to describe colors. That blue's a little bit too green, don't you think? Is subjective and hard to do. But if you're actually saying, I want Pantone this number, someone else looking at the same guide can at least say, okay, we agree that there's a shade of blue that we're both trying to match. That is the best thing about it. However, that falls short because not everyone's willing to pay for spot color. So True Match and Focal Tone really win the day by giving you a chance to show clients swatches, but they're all CMYK builds, so they don't cost anybody any extra money. Isn't that great? Okay, let's talk about image editing software. Image editing software is the facial tissue of Kleenex that is the generic term for Photoshop. There are other programs that can do it, Photoshop being the most famous. And image editing software edits pixels. Pictures taken on digital cameras or scanned using digital scanners are made out of pixels, which again, because this is a review, there's no shame in saying it again, are little tiny squares of color. Each square in the grid makes up one color. How good a color and how many different types of colors can you have? That depends on the amount of data or memory that you assign to each pixel. Typically speaking, on the modern computing softwares and the modern cameras and modern Photoshop, you're looking at millions of shades of color possible because you have 256 levels of red, green, and blue light. And the combinations by multiplying those by each other of how many different variations there are per pixel. That does also mean a lot of memory. So pixel is short for picture element. Pixel images are something called resolution dependent. I know it was just tax season. That does not mean you can claim them on your IRS bill. Trust me, you'll be audited. These resolutions are dependent on me. My digital photography stuff here is clearly another mouth to feed and another deduction. That's my attempt at tax humor. Happy tax season, everyone. Anyways, resolution dependent means you only have so many pixels to print with in the image. The number of pixels is the number of pixels. If you make the image bigger, you still have the same number of pixels, and the coverage gets bad and the pixels gets big and it looks jaggy. I'll zoom in here as well because zooming in helps you see the problem better. As you zoom in, you lose, okay, scroll the correct direction, computer. You lose the ability to see what it is you're looking for. Again, that biggest lie in Hollywood. And although I love the original Blade Runner, I still cringe at the whole image enhance scene where Ford is there talking to his computer. Sorry, his name in the show is Deckard. Just looking at his computer saying, computer, enhance. And the computer zooms in, chick, 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 computer, enhance. Computer, enhance. And then you get to this. This is what a pixel image looks like if you zoom in enough. The only reason it looks like anything but this nonsense is because the pixels get smaller that your eyes/brain are not able to tell them apart. That's how it works. You make these dots of color so small that you can't see the difference between the dots, and it looks continuous color to you, but it is not. It was always pixels. It was always these squares. If you make a picture bigger, all you're doing is making the squares bigger. There we go. Ooh, so when you make it bigger, you lose image quality. That's a pixel image. Vector graphics are the other type of graphic on a computer. Cameras and scanners cannot make vector graphics. Vector graphics need to be generated on the computer itself. Vector graphics and illustrations are made in like Adobe Illustrator and also CorelDRAW and a few other places. But those are made by making shapes. The computer sees corners or points, and it sees lines that connect those points. And when they connect all the way around and go back to their starting point, then they're a shape. And you can have a fill color or fill gradient or fill texture inside that shape. The beauty of a vector is you can make it as big as you want it and it will never lose quality. A vector, when preserved properly, if you print it on any press, will always print at the maximum resolution that that press can manage at the size that you tell it to print. Because a vector graphic is not a pixel graphic. It doesn't have a size until you print it. It is in fact blueprints, an instruction to the computer about how to make the shape you want, not the shape itself. And so it can build that shape at any size you want. A vector graphic will work equally good on a postage stamp design and on a billboard sign. Both of them work because it doesn't have a size. The size is whatever you ask it to be when you send it to print. All right, I'm going to stop this video here, and we'll come back with page layout software next time. Thanks for listening, as always.